The origin of replication is where the helicase starts unzipping the DNA double helix. The proteins initiate the replication by attaching it to the DNA, separating the two strands and forming a replication bubble. The single strand binding protein holds the leading and lagging strands apart and prevents the strands from repairing the bond. The primase sets an RNA primer for the polymerase to continually add complementary nucleotides. The triphosphate nucleotides lose two phosphate atoms, and the energy released is used to bind the nucleotides to the DNA strand. DNA polymerases cause the synthesis of new DNA by adding nucleotides to the pre-existing chain. For example, the thymine connects to the adenine. When the DNA helicase opens up the replication fork, the result is two parent strands called leading and lagging, which are exposed and waiting for new nucleotides to be added on. The leading strand's free end is 3' and the end that's nearest to the replication fork is 5'. DNA polymerase starts at the free end, working in the 3' to 5' direction and runs continuously toward the replication fork. The helicase continues to open up the line. The more the helicase opens up, the more nucleotides are added. This only occurs on the leading strand. The lagging strand is composed of Okazaki segments that form on the lagging template during replication. When the replication fork opens up at the 3' end, at the base of the fork and the 5' end at the opposite side. The discontinuity begins when the helicase moves forward and exposes more lagging strand in front of the starting. Once the Okazaki segment is formed, the DNA polymerase 1 replaces the RNA nucleotides of the adjacent primer with the DNA nucleotides. Once the polymerase reaches a section it has already replaced, it stops. The final nucleotide of the replacement DNA segment is bonded by the DNA ligase to the first DNA segment by joining the sugar phosphate backbones of all the Okazaki fragments into a continuous DNA strand. Once the Okazaki segment is formed, the DNA polymerase 1 replaces the RNA nucleotides of the adjacent primer with the DNA nucleotides. Once the polymerase reaches a section it has already replicated, it stops. The final nucleotide of the replacement DNA segment is bonded by the DNA ligase to the first DNA segment by joining the sugar phosphate backbones of the Okazaki fragments into a continuous DNA strand.